Okay, we are starting with number 60 in the review notes. So as I look at 60, we are graphing, and what types of functions are these as I look at 60? It's blurry still. So I look at 60, what type of graph is this?
Linear.
It's not linear. You think it's linear because it's x to the first. So that's a good guess. I'll give you a piece of candy for that. Good job. I'm feeling generous today because it's Monday. Who answered that? Dylan? What type do you want? Snickers, Milky Way, Three Musketeers.
Snickers.
Okay. Nice catch. Okay, so we don't have linear. So look at your function and tell me what you notice about it. You would say linear because you see x to the first. But what else do you notice? Do what?
There's 2 lines around it.
Okay, there's 2 lines around it. What are the 2 lines around it? No? Absolute value. So this is an absolute value function. We have not talked, guys, listen up please. We have not talked about absolute value functions, graphing it in this class very much. This is what an absolute value function will look like. So quadratic equations will look like a what when I graph it? If I graph a quadratic equation, it will look like a what?
Positive.
No. What will the graph look like if I'm graphing a quadratic equation? No, quadratic. You guys should know this. If I graph a quadratic equation, what will it look like? Parabola. It will look like a U shape. If I graph a linear equation, it will look like a what? Line. If I graph an absolute value, it will have a V shape, and the origin will be at 0, 0. So this is called the parent function, or kind of the original what absolute value function will look like. We haven't talked about it in class before. Whenever you see absolute value function and it says to graph it, it will look like a V shape. Now, can anyone tell me why the graph is not going to be anywhere underneath the x-axis? It's not going to be anywhere underneath here. For a piece of candy, can someone tell me why it will never, at least for this class, be underneath the x-axis? Sean?
Absolute value is never negative.
Okay, the absolute value can never be negative. So what does that mean, can never be negative? You're on the right track. He says absolute value can never be negative. So look at your y equals absolute value of x. What does that tell me can never be negative? You're just saying stuff. You're not actually thinking about it. Look at your graph. I said it can never go below the x-axis. Absolute value we know can never be negative. So look at your equation. What does that tell me can never be negative? Some of you guys aren't doing what I'm doing, but that's fine. You can not look at it, the screen as I'm talking about it. It's y equals the absolute value of x. So if I know the absolute value can never be negative, what does that tell me can never be negative? No? You guys do what? More specific. Huh? Look at your equation. If y equals the absolute value, and I know the absolute value can never come out as negative, what also can never be negative? No, look at your equation. If y equals an absolute value of x, what else does that tell me can never be negative? More specific. You guys are just saying, think about it. The y, that's fine. This is part of figuring it out and learning. Think about it. Y equals the absolute value of x. So if I know if I plug in any number for x and I put it in the absolute value, it will always come out positive. What does that tell me will always be positive? Y, because y equals the absolute value. So any number I plug in for x, I will always get back a positive y value. Why does that make sense with the graph? It never goes down below the y-axis or the x-axis, so it's never going to give me a negative y value. If it gives me a negative y value, then I would go down here. But since y is equal to the absolute value, y is always going to be positive. Okay? You're fine. Yeah. Yep, I will. Yeah. I will get on to the head. The homework is 63:1 today. The notes will be on there later today. Okay, so as I look at this, as I look at graphing these, guys, listen up. As I look at graphing these, we are thinking we are going to have that V shape. And since y is equal to the absolute value, we're thinking that it's all going to be above the x-axis. I'm not going to have any negative values for my y values. So as I look at graphing something, how do I always graph something if you have no idea how to do it? Like we talked about slope-intercept form, and we talked about how to find the vertex and all that stuff. If you forget how to do that, what can you always do if it tells you to graph something? You learned it in middle school. We did it a little bit in class this year. Find points. Make a T-chart. If it says graph and you don't remember any of the shortcuts, always just make a T-chart and just start plugging in points and finding points. So you can always resort to that if you're not sure how to use a shortcut, like slope-intercept form or how to find the vertex or any of that stuff. Let's go ahead and start some points. -2, -1, 0, 1, and 2. Those are kind of some basic points to start with. Since I notice this absolute value, I'm going to have to get that V shape eventually. So I'm looking for that V shape. If you do not have a calculator, go grab one, please. The math in this is not very hard. You probably wouldn't need a calculator, but you'll need it later.
Okay, so these aren't ones that you set up to, like, take it out.
No.
You can't do it that way.
Because you're graphing, so no, there wouldn't be two equations. Okay, so as I look at, I guess you could, but no, we don't teach that way. So as I look at -2, we're going to have, plug in a -2, absolute value of -2 minus 4. What is -2 minus 4?
-6.
Absolute value of -6? 6. So -2, 6 is 1 point. So you're going to go through and plug in your numbers. Now plug in -1. Y equals the absolute value of -1 minus 4. What is -1 minus 4? And the absolute value of -5? 5. So we're looking for that V shape. And some of this you can kind of do in your head. If I plug in a 0, I get what?
4.
-4, absolute value of -4? 4. If I plug in a 1, I get a what?
3.
-3, the absolute value of -3 is positive 3. If I plug in a 2, I get a what? 2. So as I plug those points, -2, 6, -1, 5, we're looking for a V shape. 0, 4, 1, 3, 2, 2. Do I have a V shape yet? No, it looks like I have what side of the V? The left side. So what would be a good point, maybe X value to plug in to try to get the right side of the V?
3.
Well, it looks like it's going to keep going down. So what would be a good value over here that would probably give me a point over here so I could draw the V shape? Yeah, let's try 6. If I plug in 6, what am I going to get? 2. So 6, 2. Okay, now I will give you a hint as well. Whatever number is in here, the opposite of it is the point on the V. So if this is x minus 4, then 4 is going to be the point on the V where it switches direction. So that's kind of a hint that can help you. So if you plug in points and you don't see the V right away, this opposite value here, so if it's x minus 4, then x equals 4 is where it's going to be a point at. So I know we haven't done it, but it's really just plugging in points and looking for that V shape. Okay. Any questions on that? Okay, let's look at one more of those. Let's flip to, let's look at 62. So as I look at 62, let's start plugging in points. So if you ever graph something and you don't know how to do it, just make a T-chart. So we'll start with -2, -1, 0, 1, and 2. And hopefully from doing that, I can see the V shape. So if I plug in -2, this stuff you can kind of do in your head, but I'll just write out a couple examples. If I plug in -2 for X, I'm going to get back what for Y? Huh? Absolute value of -3, which is what? 3. So I'm going to get back -2, 3. If I plug in a -1, I'm going to get the absolute value of what? -2, which is 2, because -1 minus 1 will give me -2. If I plug in 0, I get back the absolute value of -1, which is 1. If I plug in 1, there's your 0. The absolute value of 0, which is 0. And if I plug in 2, I get back 1. So as I start graphing those points, -2, 3, -1, 2, 0, 1, 1, 0, and 2, 1. Do I see that V shape? Yep. So go ahead and connect your points. And there it is. So even though we haven't done it, it's not that hard. You're just plugging in points, and we're looking for that V shape. Anytime you have absolute value, it's always going to look like a V. Okay, any questions on that? Okay, let's look at the next section. Solve each system by graphing. So if I'm looking at solving each system, a system means 2 or more equations. For this class it will be 2. How do I solve a system by graphing? Let's look at 65. If I want to solve the system by graphing, tell me how I would do that. That's by elimination. We'll do that in a second. If I want to solve each system by graphing, what am I looking for? How do I do it? Nope, I'm using graphing, not substitution.
Okay.
We'll do that in a second.
Would you like graph like a negative? Would just be like the regular how you graph, but you graph 2 lines instead of 1.
Okay, yep, I'm graphing 2 lines, so graph them both separate. And if I want to solve this system, I want to know what about the lines? Where they intersect. So this is the same idea with inequalities we did last week, but we're not shading. So for systems of equations, you graph both lines and you see where they cross. That will give you the ordered pair where they work for both of them. That will give you the ordered pair, that's the solution. So we're looking for the x and the y value that work for both of them. So graph both of them like normal, see where they intersect. So if I look at 65, I'm graphing the top one. Now you know that it's in slope-intercept form. So what is the slope and the y-intercept for the top one? Is the, what's the -4? Y-intercept is -4, the slope is 5/4. So as I go to graph this, we graph the y-intercept first, so go down 4 on the y-axis. How do I get the next point? 2, 3, 4, 5. Which direction 4? Right 4. So up 5, right 4, because that is the slope. It is a positive slope, so my line should be going uphill. And then my second equation is already in slope-intercept form. Slope and y-intercept for the second one. Slope is 5/4. Y-intercept 3. So I'm going to go up 3. That's my y-intercept. To get my next point, I'm going to have to do what? 1, 2, 3, 4, 5, and then left 4. 1, 2, 3, 4. Since I can't go up 5, I have to go down 5, but I have to keep it positive, so I have to go left 4. I have to keep it positive. So as I look at these two equations, or these two lines, I notice they are what? Parallel. So what is my solution going to be? No solution. Since they do not intersect at any point, they are no solution. Now, for a piece of candy, without looking at your lines, how could I tell that these lines were going to be parallel just by looking at the equations? Sean? Slopes are the same. So if you notice, the slopes are both 5/4, so you should notice right at the beginning, before you even graph them, that they're going to be parallel because the slopes are the same. Which kind do you want? Snickers, Milky Way, Three Musketeers.
I'm glad cake. I don't like it.
Nice catch. Okay, let's look at the next one. Let's look at 66 real quick. So as I look at 66, let's go ahead and graph these two lines. These are linear because it's x to the first. And see where they cross. Okay, so as I look at 66, the top equation, my slope, guys, listen up please. My slope is going to be what? -1 or -1/1. My y-intercept is what? Also -1. So I'm going to go down 1 to my y-intercept, and then up 1, left 1. I have to get that negative. So since I go up 1, that is positive. So I have to go left 1, because that is the negative. My line should be going downhill because it has a negative slope. Second one, we have my slope and y-intercept. It's already in slope-intercept form. Slope is what?
4.
2/3 is my slope. My y-intercept is 4. So we're going to go up 4 to my y-intercept first. And then my slope, I'm going to go...
Down 3 or left 2?
No, rise over run.
Or
You go
down.
down 2 and then up 1.
1, 2, left 3. 1, 2, 3. Okay. Yeah. Okay, so as I look at this is why we probably should use rulers. If I look at this, hopefully your line is better than mine. We're looking for the point where they cross, and you can kind of see that my line kind of goes because I didn't graph it very well. If I would have graphed it straight, what point does it look like it crosses at?
-3,
-3, 2.
-2.
So my solution is -3, 2. So when I'm solving a system, you always need an x and a y value, the ordered pair where they cross. This is why we don't use graphing very often, is because sometimes your lines suck and sometimes it's hard to see exactly what points they're going to be. Okay? Which is why we use substitution and elimination as we're looking at 68, the rest of these. So as I look at 68 real quick, 68 through 70, we are using substitution. So as I look at 68 through 70, what do you notice about the way these two equations are set up that will tell you substitution will be the easiest?
1 is y equals.
1 is y equals. So we're looking to literally substitute something in for something else. And we notice on 68 through 70, you already have an equation that's y equals. So it already kind of tells you what you can substitute in. So as I look at 68, this tells me that I can take 2x plus 12, because it is the same thing as y, and plug it in where? In the second equation. So since 2x plus 12 is the same thing as y, it is equal to y, I can plug it in where y is into the other equation. So I'm going to have 3x minus 8 times 2x plus 12 equals -5. We are literally substituting it in for y. So you don't have any y left. If I have a substitute teacher, they take my place. I'm not here. They are in place of here. So if 2x plus 12 gets substituted in for y, there's no y there. You just plug it in where y is. So as I go through and I want to solve this equation. I have an equation with just x in it. How do I start solving this equation?
That thing.
That thing is called,
Put 3x down,
okay,
and then, is that negative?
negative 8, yes.
So go do this thing, or you go to
You're good. So what will it be?
you multiply.
Okay. Which will be what?
16.
Negative 16x.
Squared. Oh no, I don't know.
Okay. And then negative 8 times 12. Which is?
Negative
96? Yeah,
Yeah.
96. Sorry, 96.
Trying to say 72. I think it's 72 that.
Sorry. My bad. Okay, so as I look at it, negative 8 times 12, we're distributing. So negative 8 times 12 is negative 96. So I have an equation that we can solve for x. What do I do next? Someone tell me, you guys know how to do it.
Can you combine the two?
Yep, so what's 3x minus 16x? Negative 13x, good. Minus 96 equals negative 5. What do I do next? Plus 96. So negative 13x equals 91. What do I do next? By negative 13. So what is 91 divided by negative 13? Negative 7. Now this is a system. So think back to what we just did with graphing. We needed ordered pairs and answer. So if I know x is negative 7, what else do I need to find? The y value. Now how do I find the y value? Plug in negative 7. Use the equation that's already y equals. If I want to know the y value, use the one that's already y equals. 2 times negative 7 plus 12. 2 times negative 7 plus 12. Negative 14 plus 12. So my ordered pair is negative 7, comma, negative 2. X, comma, y. Okay, any questions on that? Yep. Okay, let's look at elimination, 71 through 73. So let's go ahead and look at 73. Let's look at 73. Okay, as I look at using elimination, if I look at 73, why would substitution not work for 73 or not be the best option? Because what?
Y equals or x equals.
None of them are x equals or y equals, so you don't know what to plug in for x or what to plug in for y. So elimination is the best choice. So in order to be able to eliminate something, I have to have what? Opposite equal. So same number, same coefficient, opposite sign. Because when I add, I want them to cancel. So as I look at 73, which one would be easiest to get the same number opposite sign, the x's or the y's? So look at your x's and look at your y's. Which one would be easiest to get the same number opposite sign? The y's. Why would the y's be?
Because you can
Keep going. You're on the right track.
find 2 by negative 4.
Yep. So she notices that there's an 8y in the bottom equation and there's a 2y in the top equation. And she wants to get the same number opposite sign. So she asks herself, is there something I can multiply 2 by to get negative 8? Negative 4. So we're going to take a negative 4 and multiply it through my top equation. So I have same number opposite sign. You have to multiply everything by negative 4. So it will be 28 positive 28x minus 8y equals negative 100. That's my top equation. Multiply everything by negative 4. Your bottom equation I'm not changing. So negative 9x plus 8y equals 5. The reason we're doing that is so we can eliminate something. We can eliminate the y's when I add them together. So when I add these together, what am I going to get?
19.
Yep, 28 plus a negative 9 is 19x. The y's cancel. Equals negative 95. Divide by 19. X equals negative 5. Now this is a system. So I need an ordered pair. So when I found x to be negative 5, how do I find y? Once I find one, how do I always find the other one? Plug it in. Now, here's kind of the downside of elimination. None of these equations are y equals already. So you're just going to have to pick one and plug in negative 5. So I'm just go ahead and choose, I'll just choose the top one. It doesn't really matter. So negative 7 times negative 5 plus 2y equals 25. It doesn't matter if you use the original equation or the equation after you multiply negative 4 through. I'm just going to use the original one because the numbers are a little smaller. So I take a negative 5 and I plug it in where x is. So negative 7 times negative 5, positive 35, plus 2y equals 25. Now solve that equation for y. So I need to do what? Minus 35, minus 35, 2y equals negative 10. Do what? So y equals, so my ordered pair is negative 5, comma, negative 5. System, we always need an xy value. Ordered pair is an answer. Okay. Any questions on that? Okay, let's look at the next clump. Some story problems. So let's look at 74. Okay, we're going to skip out the last couple. I'm probably going to take a couple off the last ones just so you have time to work. We'll see what time it is. Okay, let's look at 74. This is a story problem. So, senior class at high school A and high school B plan separate trips to the water park. The senior class at high school A rented and filled 3 vans and 4 buses with 162 students. High school B rented and filled 1 van and 12 buses with 342 students. Each van had the same number of students in it as did the buses. Find the number of students in each van and each bus. It is a story problem. So what do I do first on a story problem? Find what they are looking for. What are they looking for? Number of students in the van and number of students on the bus. So once I find what I'm looking for, what does I'm trying to think grammar. What does that become? So what am I looking for becomes the what in my equations? The what? So whatever I'm looking for usually almost always becomes the what part of the equation? The variable. So I'm going to let V be the number of kids in a van, and I'm going to let B be the number of kids in the bus. So just because it's a story problem and it looks complicated because there's lots of information, you still start it the same way. Look for what they're asking for. Whatever they're asking for becomes the variables. So the number of kids in the van is V. The number of kids in each bus is B. And they're going to give you information so you can set up your 2 equations. Don't keep your head up, please. So as I look at this, let's look at the first one. The first one, they tell me, high school A rented and filled 3 vans and 4 buses with 162 students. So what would that look like? If I know I have 3 vans and 4 buses and 162 total students, how do I represent that in an equation? Look at your variables. Think about it. It's kind of common sense. If I know in total I have 162 students,
3B plus 4B.
3 what?
What do you write?
4B plus,
40
just a second, 162. So as I look at it, kind of think about it. V is the number of kids in the van. So if I know there's 3 vans, to get the total number of kids that are in the vans, you're going to take 3 times the number of kids in each van. So 3 times V. To get the total number of kids in all the buses, you're going to take 4, which is the total number of buses, times however many kids is in each one. So 4 times V, and that will give you 162 total. Does that make sense? Yes? Okay, what will my other equation look like for high school B? Okay, so B plus equals 342. I have one van, so I have the number of kids in one van plus 12 buses times the number of kids in each bus. And now I have 2 equations I have to solve this. So you have to ask yourself, elimination or substitution. Hello? That's okay. No, it's not.
You like it?
No, I have a 5th block, but okay, perfect. Okay, thanks. Bye. Okay, so as I look at this, are we thinking elimination or substitution? We could do substitution easily. How could I get B by itself?
Minus 12B.
Minus 12B. We could do it that way. I don't really care. I like elimination better. So what would I need to do in order to eliminate?
Multiply -3.
Multiply the bottom. If I take the bottom equation and multiply by -3, that'll give me a -3B. So as I look at the -3, we're going to take a -3 and multiply my bottom equation by -3 so that I can eliminate the V's when I add them. So I'm going to have my bottom equation is going to be -3V, and then what? -36B equals negative what? 1026? Like that? Okay, so that becomes my bottom equation. I took a -3 and multiplied through. Now, you're going to have a calculator for this. As I add down, what happens to the V's? They cancel. How many B's am I left with? Negative 32B equals 162 plus a negative 1026. $864. Divide by -32. So B equals what? What is it? Okay, think about it. Does that make sense? If B is the number of kids on a bus, is 27 an okay number?
Yeah.
Yes, you weren't going to get a negative. You should not end up with a negative. You're probably also going to get like 256. You're not going to have 256 kids on the bus. So it should always kind of make sense. Now, have I answered both the questions? No, I also need to find what? How many kids in a van? So let's plug B into the original top equation. So it doesn't matter which equation you choose, I'll just choose the top one. You're going to take your B value and plug it in where B is. And now I can solve this for V. So 4 times 27. I really don't know off the top of my head. 108. So 3V plus 108 equals 162. Minus 108. Minus 108. 3V equals what? 54. Divide by 3. So V equals what? 16? 18. Okay? So 18 kids on a van, so it makes sense. Okay? Any questions on that? Okay, we're going to look at one more story problem. I'm going to cut off the last section, just because I want to give you time to start on these. Okay, let's look at number 76. Let's look at 76. These are some interesting names. Shreya and Narachi are selling flower bulbs for a school fundraiser. Customers can buy packages of tulip bulbs and bags of daffodil bulbs. Shreya sold 4 packages of tulip bulbs and 12 bags of daffodil bulbs for a total of $104. Narachi sold 9 packages of tulip bulbs and 6 bags of daffodil bulbs for a total of $87. What is the cost for 1 pack of tulip bulbs and 1 bag of daffodil bulbs? So what am I looking for?
The cost of one package is 2 bulbs.
And 1 package of?
3 bulbs.
Okay. So we're going to let T be the cost of tulips, a tulip bulb, and D be the cost of the daffodils. So T is going to be the cost of tulips, and D is going to be the cost of the daffodils. So as I set up my 2 equations, we are looking at, your phone needs to be away. You don't need your phone out. I'll see. I already had this discussion with you. So T is the number of, excuse me? No, that's not going to be accepted in here. Do we understand? Do we understand? Or do we need to go down to the D? Okay, then you can head down. Excuse me? I don't like being called stupid. Okay, awesome. Okay, so as I look at this, we are looking at setting up my 2 equations. Yeah, I'll check in a second. So as I look at this, we have the number of tulips, or the price of tulips, and the price of daffodils. So we need to set up my 2 equations. So as I look at setting up my 2 equations, what's my 1 equation for Shreya going to look like? So she bought 4 packages of tulip bulbs and 12 bags of daffodil bulbs, and they give us the total amount of money she spent. 12 D equals what? Okay, because that tells me how much money she bought. So if she bought 4 bags and each bag costs $T, that's 4 times T will give me the total. She bought 12 bags and each bag costs D, so 12 times D will give you the total amount of money she spent on the daffodils. So that's 104.
She sold it.
Okay, sold them. That's how much she sold them for. That's true. Yeah, the cost. So that tells you how much she made. Sorry, I used the wrong words. Narachi. That's a good name. I don't know if I'm spelling it right, but that's a good guess. What would the equation for Narachi look like?
9
Plus
6
equals. Okay. As I look at this, we have to decide elimination or substitution. It's kind of an easy one to decide between. Yep. And which one would be easiest to eliminate, T's or D's? D's. And what would I need to do to eliminate the D's? Multiply by -2. So we're going to take my bottom equation and multiply by a -2. That way we can have a -12D in the bottom equation, so we can add and there cancel out. So as I look at these, my bottom equation is going to be -18T minus 12D equals 174. My bad at mental math. 174? Okay. So that's my bottom equation. Dylan, keep your head up, please. So as I add down, what am I left with my T's? 4 plus -18T. -14T. D's cancel equals what? -70. Divide by negative 14. T equals what? 5. Should be a positive 5. And let's see if this makes sense. $5 for cost of tulips. Yeah, it's doable. That makes sense. So T is 5, and I need to find the cost of the daffodil. So how do I find that? Yep, and I'm just going to use the top equation. It doesn't matter which one you plug back in for T. I'm just going to use the top one. So 4 times 5 is 20. 20 plus 12D equals 104. How do I solve for D? Subtract 20 minus 20. 12D equals 84. Divide by 12. D equals what? 7. So $7. So that makes sense. So it should make sense in context. Okay, so I'm going to, the last section we're not going to get to. So you are only in your review packet. It'll